I would have a warm welcome to all of you who have joined for the second episode of the Expert Exchange 2.0, which is our exclusive webinar series designed to inspire, educate, and connect minds across the scientific community. Good afternoon to all joining in from India, and good morning to our global audience tuning in from around the world. I am Anak Goswami, DGM Marketing at Acumex Lab Devices, and I'm honored to be your moderator for today's session. At Acumex, we are proud to be more than just a product solution provider. Headquartered in Ahmedabad, India, with world-class manufacturing facilities across India and Germany, we have been at the forefront of laboratory innovation since 2003. But beyond products, our vision is to be your partners in progress, committed to sharing knowledge and empowering the next generation of researchers, innovators, and the problem solvers. That's what Expert Exchange 2.0 is all about. Today, we are privileged to have with us two distinguished thought leaders from the industry, Dr. Sachidanand Singh and Dr. Tejas Shah, who will be sharing their insights, experience, and practical wisdom that can support and inspire researchers at every level of today's topic, PCR Plastics Uncovered. Our first panelist today is Dr. Sachidanand Singh, who heads Department of Biotechnology at Pandit Dindayal Energy University, Gandhinagar. He has pursued his PhD and postdoc from Ohio State University, USA, with 14 years of experience in teaching, administration, and research. His research area includes plant biotechnology, metagenomics, system biology, and NGS. He has published more than 60 research articles in peer-reviewed journals with 9 patents published. Sir, it's truly a pleasure to have you on our panel today.
Thank you.
Our second panelist today is Dr. Tejas Shah, who is currently heading Molecular Biology Department at Krishna Diagnostics, Pune. At Krishna, he is involved in working with various infectious, oncological, and reproductive health-based assays using emerging technologies like ddPCR, NGS, microarrays, and several others. With over 13 years of experience in the field of molecular biology, Dr. Tejas has pursued his Masters of Molecular Oncology from European School of Oncology, Spain, and a PhD in molecular genetics. So we are delighted to have you with us today.
Thank you. Thank you very much, Anup.
So, all the participants who have joined us for this webinar, thank you for being here. If you have any questions during the session, please feel free to drop in the chat box. We'll address them all one by one after the panel discussion gets concluded. Now it's the time to begin our panel discussion, a session packed and thoughtful questions designed to tap into valuable insights and experiences of our esteemed panelists. So I'll start with Dr. Sachidanand with the first question on the panel. What are the key factors to consider when selecting PCR plastic consumables for high precision application, especially in terms of manufacturing process of these products?
Yeah, so thank you so much, and I'm really happy to be part of this type of interaction. And I really thank you and your Acumex team to bringing up these type of opportunities where people interact for the consumables and the chemical which is required. So thank you once again. Connecting to your question, Anak ji, I am from an academic institution presently, and my concept right now to understand or to select a PCR plastic as a consumables for high precision applications would be more towards my students' concern. So I need to run my department with 120 student strength for molecular biology lab or a genetic engineering lab. So they come for a 4 hours of lecture, 4 hours of practical. So I need to see a consumable and chemical which is reliable and has to give me a result specifically during that experimental time, because this is for the demonstration and the hands-on for the students to do. When there is a matter of research, that's another aspect. So my first input will be my instrument compatibility and the shapes of my PCR plastic and consumable. They should be really very specific and adjustable to my thermocyclers. That should be my first thing, which I think when I select my PCR plastics and consumable.
Yeah.
I'll also think in sense of not very specifically. Of course, if it is my research, cleaning, manufacturing is playing a major role. We do a lot of ISO certification. We also see from where it is coming up. But the most important thing we would see that it should have a reduced risk of our DNAs and RNAs decontamination should not be there out of it.
Certainly.
Surface quality also should be a matter of concept which should take care. So when I see a experiment when it is happening, and when my faculty or my scholars perform it before, when we have to run this same experiment with my 60 students keeping a batch of 4, it has to give me a precise result. None the matter I have got a good results before, but it has to give. So that is my first thing. Second or a third thing which has to come up, so uniformity is of my PCR or a thermocycler which I am using. It should have a very specific and it should ensure the efficiency and uniform heat transfer should be there. It should have a well shaped volume and concept of my consumable which I am using it up. So these are some very important things which I think it should happen, and we should select in that way. When it is my research point of view, my purity of the consumable which I am taking has to be very important. Background introduction to my background fluorescence should be one component which I should really see about when I am doing a qPCR. So these are
Yeah.
something which I really think it should be seen while selecting a PCR plastic consumable.
Certainly, certainly. Very crucial factors which you highlighted, sir. Dr. Tejas, what do you think, like, what are some key factors to consider when selecting a plastic consumables for the diagnostic applications, basically in your purview, wherein the setup which you take care of?
Sure. So I would like to divide this question into two halves, right? So one thing, when we talk about manufacturing, no doubt the certifications like ISO, clean room, all matters, right? So the injection molding in dedicated clean rooms where ISO I think 7, 8, and more better, critical components have been considered. So what we called it in normal language is PCR graded, right?
Yeah.
Consumables that have to be considered, right?
Mhm.
Then there have to be certain, what Dr. Singh also said was it should be compatible. So the mold design should be compatible, or else, at a times they get crunched or the evaporation, takes off. So these things are mandatory. And when we talk at the lab level, then optical properties matter, because that background autofluorescence, reduces the signal to noise ratio, and then it drastically shifts the CT, and all our diagnostic calculations are based on CT values. So if there is a
Right.
shift in CT values, all your copy number variations, all your calculations, the ratios, they change drastically, which might give you false negative, false positive results, right? So
Yeah.
when we talk about diagnostics, yes, this thing matters. And then, small things like dimensional tolerance, the well geometry. At a times during COVID days, precisely, we used to find that the few wells were not uniform. Maybe it was a manufacturing defect, but that time I understand it was the burden on the industry as well. But yeah, these things need to be taken care of when we precisely think at the diagnostic level. Per se, R&D also, it makes a sense.
Absolutely, absolutely. And as you rightly mentioned at the start of your, comments on this question, it is more about the manufacturing processes also. So it should be aligned to what is required in the market. Yeah.
Right.
Dr. Sachidanand, a second question to you. It talks about the contamination, right? So contamination. When we say this, when we listen this word, it's the biggest of headache, which is something which we have to take care of, right? So what are the most common sources of contamination with PCR plastics? And what do you think? How can they be effectively controlled or minimized?
Yeah, so a great question, and this I'm from since last few months. I'm listening from my faculty, scholars, and all those stuff. So I'll just brief you out a little bit about my setup in Pandit Deen Dayal Energy University. We are just a 24 months old department, and due to our fundings and showing a good response towards biotechnology, Government of Gujarat, PMO office, Pandit Deen Dayal Energy University is supporting us for establishing a biosafety level 3 facility. So I would really like to share this with Dr. Tejas also. So we are coming up with biosafety level 3, but of course it is for bacterial research, MDR strains and TB we are mainly focusing, because in Gujarat we don't have in academic institutions a BSL3 facility. So that is something which is coming up recently. So the thing is, the first thing what we are establishing, and it will take a long way, sir, around 9 months to set it up. So the major issue what we are seeing this place and the facility is more towards the contamination portion. So so very specialized area we have done. So the word contamination is all around from last few months. So if we see specifically for PCR plastics, as an academician, and right now putting up my lot of funds towards this, when my students and my technical staff works upon and they perform these type of PCR reactions, the first thing is human handling. So I understand the procedures, the best SOP written will always give us or avoid contamination. So that is more important thing. Then when the contamination word is there, a routine disinfection is the most important aspect which has to be taken care. Regular inspections, when the sterility thing for our portion, that is cleaning and packaging portion, sterile bags, what we are trying to do is that is a portion which need to be taken as a control measure for a contamination source. So if you see specifically for a contamination where it originated, I feel it's a human handling is the first component, which is which can be restricted by gloves. Equipment, yes, is one portion where a regular cleaning is required. Second is your environment where it has been established. So a skin or a poor hygiene or the airborne particles can be the another one component. So so these are something which I understand is a contamination sources for which we should really look into for the control measures for it. So ISO classes are there, and as I said, our growing procedures for staff, daily routine dispensation procedures are there. A lot of DNAs and RNAs testing need to be checked it up as a biological component. So that is also one portion which need to be looked upon as a control measure for contamination source.
True. Dr. Tejas, with reference to diagnostic scenario, it's quite critical, I would say, wherein a human sample is wherein we are testing it, and it's very critical for us to provide an accurate result. So, how does contamination hamper over there in your setup?
It matters a lot, very frankly. And per se, because we are into diagnostics, we are completely monitored by NABL and CAP, right? So one of the things when auditors come is they will always check what is the contamination, in your ratio in your lab, and how do you eliminate them. So this question is quite relevant when you work in the diagnostic setup. There are multiple things. So one is environment and aerosol contamination. As Dr. Singh rightly said, that BSL3 will help both the internal, the bacterial going out and the outside contamination getting in. So that's the one thing. The other beauty of the diagnostic is because NABL has clearly said that the pre-PCR and post-PCR setup has to be completely different, right? So that matters when we work in the diagnostic setup. So it completely eliminates the aerosol contamination. The second major what we find here is because we at times have major chunk of load because library preparations in the PCR plates and stuff. So there is a carrier of amplified product. So at times you have to be very sensible enough to understand whether it's a contamination or a carrier from your previous or some pipetting handling. So that matters, and that's the tricky job, very frankly. Dr. Singh highlighted, the user-derived contamination through gloves, through skin, people wearing watches, some bands, so that matters. Apart from that, oftenly we see some RNA-specific contamination in RNA workflow and RNA library preparation. So UV and DEPC do help, So we always channelize certain partners or the consumable partners in such a way that it has to be, UV irradiated or at least DEPC treated when we go with at least workflow which have RNA predominantly, library preparation. And at very minimum level, but yeah, manufacturing contamination matters, but then certain traceability certificates do help to eliminate that.
Certainly, certainly. I think very well covered. You already covered, what are actually the do's and don'ts, you need to remember while you are handling the PCR plastics. Dr. Sachidan, would you like to add something on some more do's and don'ts if you've come across, which are important for us during the PCR plastic handling?
Yeah, I think Dr. Shah has already represented the do's and don'ts, but
Yeah,
as a university point of view and a specific budget presented to us every year, I will always say always treat PCR plastics as highly sensitive lab wares. That's a heavy amount which takes up from our consumable. So we have to, being a positive point of view for these experiments, we should always wear our gloves. Filter tips should be used. Clean and regular cleaning is required. And the most important thing is we don't recommend to reuse the PCR plastics. And that I think usually in every lab it is happening. We should have a
certainly,
specified genomics or a PCR facility where we can place it up. So these are some specific do's and don'ts which I feel should be represented to the
certainly.
students and the people to understand.
Certainly. Another question, sir, to you, Dr. Singh. How important, you feel is the certification? Like, as we know, as you rightly mentioned, PCR plastics is going to be a one-time use. It is going to be a sterile stuff. But then, how important are the certifications like, DNAs, RNAs free, endotoxin levels of testing, ISO standards? How is that? How does that matter in choosing different PCR plastics?
Exactly. So, what I understand is now my second year or a first year BTech student itself is learned enough. When he or she takes up a admission to a engineering or a university, they know what is NRF ranking, what is NAC, what is accreditation. So now, when they also open their PCR plastics or a consumable, they know whether it is a ISO 9001 certified or not. At least that much they are clear. And of course, when we also see or when we identify when it is a certified one, at least 5 steps ahead they have gone to cross check their plastics or consumables that it is into a next stage. So so I feel ISO certification plays a really important role for giving us very important concepts to say that yes, it ensures cleanliness and purity. It gives me a reliability. The more the better class certification is there, it gives me that whatever expenditure I'm doing it up for my students or for my research is actually going into a correct way, so I can rely on that specific thing. So, and it, of course, there are a lot of chances of contamination, but it reduces the risk of contamination. So that is most important, which I feel.
Yeah, that's true. Dr. Tejas, would you like to add on what are your views on this
Yeah.
certification part?
So,
Yeah,
right. So when we talk about certification, something clicks in my mind is quality, right? The reason we ask for certificate is why quality care, right?
yeah,
So they basically it provides you an independent assurance and hell lot of traceability. Yes, it is manufactured in a compliance way manner. Secondly, it matters when you work with sensitive assays. Certifications like DNAs, RNAs free are critical for RNA workflows, and basically when we work with digital PCR, the low copy numbers where we go up to 0.1% of allelic frequency, right? What even NGS can't detect. When doctors feel they have to go for orthogonal testing, then it matters. A small contamination of RNA can manipulate your copy numbers. So yeah, when you work in a diagnostic setup, these things are really critical. And trust me, our purchase team without these certifications will never place an order. So yes, this is mandatory. And as Dr. Singh also said, ISO regulatory standards like 9001 for QMS, 13485 for diagnostic setup, Apart from that, now even I assume consumables and chemicals are graded to CE IVD also, right? So then this compliance also matters when we think about certifications. Yeah.
Absolutely. Absolutely. And sir, could you shed some light on the differences between, using the transparent versus the white plastics in real-time PCR? This is the most debated and
Topic.
topic,
Yeah.
and
So
how this choice impacts the assay performance, basically.
right. So it totally depends upon what are you trying to do. It's not what is good or what is bad. Both carry their own pros and cons. So when you talk about transparent plastics, it is basically required for fluorescence-based qPCR, where it's a real-time detection ongoing. Because instrument optics, is continuously monitoring your, transmitted emission through either, transparent walls or transparent bottom, and low autofluorescence transparent plastics are ideal when you work with RT-PCR. The
Okay.
disadvantage I would consider will be, it's a thin, transparent wall and can be fragile at a times. And if you the compatibility doesn't matches, the plastic might get wrapped. So that's goes with the transparent plastic. When you think about white plastic, it is used for endpoint fluorescence or luminescence assays, basically, where reflection, improves the readout, right? So the end is where you monitor, not real time. So that's where white plastic can be used, but I really doubt if I've seen white plastic used for qPCR. There might be some usage, but then you will have a transparent seal for that, if not the whole whale and bottom. I assume this is the only difference, where the transparent and white plastic may have an age above.
Because there has been always a dilemma of different, different statements around this, that whether white is
Yeah.
important or whether transparent is fine. Now, Dr. Singh, would you like to add something on this point?
Yeah, as per your Acumex and the consumable part of thing, I'll always talk in cost as well. So white plastic and transparent plastic has a different cost, a good amount of cost variation. That is also there, but I understand in sense of intensity and sensitivity. So that plays also a major role when which type of PCR you are using it up and what type of signal intensity and sensitivity we are trying to understand. I also understand ki a very general when I want to see or see a visual inspection, what is easy and what is not possible is with white plastic and transparent plastic. I'm always seeing in sense of eyes of a student. So that is one thing which I think about, and the most important thing about PCR is my signal intensity and sensitivity. So I understand with transparent it is little lower in respect to qPCR. As you said, there is always a dilemma. But yes, both are having their own point of view to utilize for qPCR or standard PCR. Yes.
Absolutely. So, Dr. Tejas, again, another question which is similar on the similar lines, like, what are the distinct roles of transparent versus aluminum when it comes to sealing foils in PCR? And again, how critical it is, to ensure the assay integrity and accuracy.
There are critical attributes while selecting the sealing foils. One important thing is heat seal compatibility, the adhesive temperature, which aluminum might have an edge over, very frankly. But again, the cost effective will always be a transparent sealing foil, be it be diagnostic, be it be R&D, right? So there are again certain pros and cons. For transparent sealing foils, the necessary when real-time fluorescence can be read out. The cons can be, must be optically clear. Nowadays, if it is not ISO certified or certain GMP compliance have not been followed, then you might get a lot of noise. And on the ceiling foils, you cannot do any troubleshooting because we don't know. That is something which will be clicked at very end of the assay. So that is one thing. Aluminum foils always have a age. They are excellent barrier to evaporation. So when we work with the higher temperature, annealing temperatures and melt curves, we always go with aluminum foil, at least at the initial level of troubleshooting and validation. And
Right.
they do have a good long thermal storage. If I have to keep in oncology, we have to store samples for 9 to 12 years, depending upon the cancer type. So with the aluminum foil, once the post PCR, we can directly store with -80 or cryopreserve it. That age plastic foil don't have. So yes, this matters, and logically, poor sealing, more evaporation, concentration changes, shift of CT, and all your results are haywire. So this is a simple logic when you choose transparent versus aluminum foil.
Certainly. Yeah. Next question again to you, Dr. Shah. From your experience, how do PCR plastic influence the accuracy and consistency of results? I mean, particularly in the workflows involving sensitive assays. We have discussed a lot till now, but critically, I would like to have your experience. How do they influence in the critical experiments?
So, again, coming back, evaporation age effect, which is scientifically proven. I'll just give you a simple situation or a observation. A lab's observed a higher CT value around the plate age and inconsistent amplifications. And the root cause was, non-compatible adhesive foils, improper heat sealing settings, which partially evaporated certain, master mix or, cocktail, we call it, which drastically hampered our, again, coming back, each and everything is revolving around the CT value, right? So
Yeah.
it significantly it hampered our CT value. And when we work with the cap and NABL, there are certain things like precision, robustness. So when a person repeat the same experiment 3 times, the values has to be within log point 0.5, right? Other way around, 3 people doing same experiment, variation among the people, it matters, right? But if your consumables are not CE, IVD, ISO approved, then the troubleshooting is nightmare. So yeah, it matters a lot.
Yeah, that's true. Dr. Singh, what is your personal experience, and what is that distinguishes high quality PCR plastics and their impact on efficiency and accuracy of the PCR experiments?
So I do remember when I was doing few of my researches with genome-wide association studies and NGS data analysis. Of course, high quality. The term represents little different of high quality plastic and low quality plastic. But yes, a plastic which attains all the standards which it has to require, which is to be required, which we have spoken the above questions discussion. So so I see and what I understand is the improvement of your CT values across the plate is very important. The reproducibility has to be accurate. So so you do a one time projection of a high quality plastic and your reproducibility is perfect. That is most important. And what Dr. Shah also said about reducing of your troubleshooting. So and your signal loss is one of the most important thing which you should always take over. So if you characterize your distinguish between a weak plastic or a high quality or a plastic which is on a standards, there should be, as we discussed before, signal detection or the intensity is one of the major important portion which we should think about. Enzyme performance is something when we start doing our experiment, it should look upon it. And contamination risk. So so with as such said, high quality plastics will have the minimum contamination risk because we say that it is a certified plastic. So that is something which I think about it.
Certainly. And what do you think? I mean, based on your vast experience, what advice would you give to the researchers and labs when it comes to the choosing of PCR plastics for long-term success?
True. So there are a number of things to be talked in sense of advice to research, lab academics, or the lab setting up their molecular biology, genetic engineering labs. We do a one-time investment for that type of experiment. So we have to see what type of plastic or the component we are taking upon. It's not about the low price or high price. It's about the standard plastic which we are taking with well certified components, which makes your results or reproducibility perfect. So the most important thing is we need to understand that your plastic which is making should directly affect your sensitivity and reproducibility. That is the first, which gives you accuracy. Second thing is you have to, or when we 95, we have to see the ISO certification, or as rightly said by Dr. Shah, the consumable or the plastic which we are taking should have a perfect embarking of how it is certified. So it should be DNase, RNase free. That is most important. The third, which I said in the very first time thing, was compatible to the instruments. So that is most important. It has to be, and a trusted manufacturer. A manufacturer who is from long, who has done a good research to develop these type of things. So that is something which I think about, that it should be advised to all of us when we take it up.
Certainly. I mean, well covered, sir. Dr. Tejas, talking about your experience into molecular biology, what advice would you like to give to the researchers and labs when it comes to the choosing of PCR plastics?
So from my experience, even though PCR plastics are one of the, deceptively small variable, right? But that can make your assay, break or sensitize. So I always believe, choose your manufacturer to the best. I always took a look first at the manufacturer controls. Is the product, molded in a clean environment? If possible, visit the site as well, manufacturing site. Is there a traceability certificate, and do I get a COA, right, with the particular lot itself? So it matters. My practical advice, require a lot of certifications. At least when I the diagnostic firm, run an incoming lot, with PCR run. Keep a strict pre and post PCR separation to preserve assay accuracy. Just in total, to as a panelist and an expert in both diagnostic and we agree that there are practical rules for the long-term success, I believe, but insist on the traceability certificate, DNS, RNS free, PCR inhibition, optical specs, if possible. If you are technically, sound person, you know what are the optics, what your PCR requires, what compatible net it is required. So yeah, it matters. And to cut short, think of a consumable as a extension of your assay, okay, not just a small part. And small saving on plastics can mean a large down cost in data losses, repeat experimentations, and delayed timelines. So at least in diagnostic, the turnaround time, what we call it as stat, matters. Reputation doesn't matter to the patient. It is onus on me as a lab head. But yeah, that matters to the physician and the patient who is suffering. So I believe you should invest in the plastics as well when you work with the diagnostic setup.
Absolutely, absolutely. That's very critical, in fact. So, I mean, yeah, and these were the great insights from both of you. I think we will now open this floor for the Q&A. I have few questions in the chat box in front of me, and participants, if you want to have more questions, you can also. We will open the session for another 10 minutes for Q&A. You can add on to your questions. I'm just taking the first question, which I see. Okay, here. Have you ever faced a situation where wrong choice of PCR plate led to failed or inconsistent result? And how did you troubleshoot it? Dr. Tejas, would you like to take this?
Yeah, it matters. It matters. The one of the aligning question to it was, white plate versus transparent plate. Yeah, so you have to be thoughtful, of what you're using. As I told in my initial discussion, also, what is good, what is bad, it's the another thing, right? So if you are in a R&D setup, I would always say go for a good NCBI papers, how they have validated what optics and what plates they have used. You have to plan your experiment accordingly. If not, at least with the field application scientist of that particular instrument. Let's see if you have ABI or Biorad, talk with them what compatible and what matters for your endpoint application, and they will be able to guide you. This is the best two solutions to troubleshoot in case you are in the same problem.
Yeah, true. The next question, which I see, I think for young researchers here, what's your one piece of advice when it comes to selecting and handling PCR plastics? I think we have covered enough on that. One last word, Dr. Singh, on that. So,
Sorry. Yeah.
uh, so yeah,
Yeah.
one piece of
So
advice. Yeah.
yeah. So the person who has asked is, as a young researcher, I will really say, if you really want your results to be on reliable, you want to publish a paper and you need to get some good results, you need to have perfectly a plastic which is self-designed and designated with good certification. So that we discovered, and we like how you can select your best plastic, PCR plastic, which will cover your whole reliability towards sensitivity and component for that. Yes.
So, there's one more question which I can see is more on the commercial angle. When labs operate under the tight budget, how can they balance cost versus quality when buying PCR consumables? Dr. Tejas.
I understand because even I am a PhD and I understand, we get very small, crunchy budget. Guide doesn't allow us, but trust me, don't negotiate on the basic consumables which are needed, because you can troubleshoot your cocktail, master mix, primer probes, but troubleshooting altogether the basic consumables is different ball game, and it's very tricky. So don't negotiate over there. You can always negotiate with people like Anak to get best price, but no, I would not encourage anything of low quality reagents or consumables. So no, for sure no.
So I'll add into this. Recently, a very specific example. We were running a small project, and due to some crunch, like how Dr. Shah said, due to a crunch, we came to a budget which was assigned to us. We saved some half of money, and we got it up, but we were not able to produce the results. So really, better to have some specific best PCR plastic consumable which we require, and run that in a one-time show. That will really give you the best sensitivity and durability, or the reproducibility which we need. And trust us, it will give you the results. You don't have to worry. So that is most important.
Uh, I have two, three more questions. We'll go fast. From your experience, what are the most common handling errors researchers make PCR plastics that could easily be avoided? Anyone, sir? Handling errors. What are the most common handling error the researchers make that be easily avoided? I think we have covered all those basic things, gloves, and so I'll go on the next question. How much does the manufacturing process of PCR plastics actually influence the accuracy of results? And what should labs look out for when choosing suppliers? Again, I think we've discussed about the manufacturing process. The last piece of it, Dr. Tejas, would you like to have it? What should labs look out for when they choose suppliers?
I personally believe they should look at the at least I'm talking in terms of compliance. Even my governing body and the CDSO people ask is the traceability certificate, lot to lot certificate, COAs. They do ask, right? You can also ask them, what are the irradiation procedures they follow. Some go with UV, some with gamma, some go with combination. So all these things have to be the part you choose your vendor, very frankly. Apart from, I always choose a vendor who gives me certain consumables at initial stage, and reciprocate the results. Okay, once that reciprocation comes between two technicians and same technicians, what I called it as precision and robustness experiment, and then we go ahead with that vendor to go ahead with the order. So yeah, these 3-4 things matters at my end.
And there's one more question again talking about, can you please brief about best choice of PCR plastic? So it all depends on application, right? Dr. Singh, you want to take this? Best
Um,
choice for PCR plastic.
so that's what I feel. We discussed about a few points, like the best and what type of reaction you are going to run about. But generally, what we spoke is to understand the reality and the sensitivity, to understand the certification, which certainly our has said, certainly about the COA, which has to be taken care. I have also learned few more things. Otherwise, we used to always see truly that a company which is under MSME, which is under a trial, which is always giving us, we were taking into assumption that if they give us some samples for initial setup to understand and see whether my lab is able to do and perform those tasks with my PCR plastic, and it is giving me a reliable reproducibility, that is most important thing. So that type of companies we should be trusted, or a manufacturer should be trusted, which should be open to represent in spite of just coming out with their things. So that is something which is very, very important and should be crystal clear to talk about. We talked about this transparent, and this one, that is of course a big discussion to happen, and which type of instrument we are using and what type of reaction has to be taken. So that is something which I would like to share.
So I think as we approach the conclusions of today's session, I have answered all the questions. I think our experts have answered all the questions that we had on the chatbot. I'd like to extend a heartfelt thank you to Dr. Sachidanand Singh and Dr. Tejas Shah for sharing your valuable expertise and insights with us. It has been truly a pleasure having you here. I hope today's discussion has provided key takeaways for all the participants who have dedicated their time for this session. Stay connected for more episodes of the Expert Exchange 2.0 webinar series by Acumex. Thank you so much.
Thank you.
Thank you, Anna. Thank you, Acumex, for giving me this opportunity. It was lovely to be, onboarded, and many more to come. Thank you very much.
Thank you so
Thank you
much.
very much.
Thank you.
Thank you, sir. Thank you so much.